Hi everyone, in this set of videos I'd like to take a look at the logic of a hypothesis test. Your textbook mixes confidence intervals and hypothesis tests, and while they are both represent inferences on the population, they are distinctly different, and so I want you to understand the difference of them before you start working on your homework. So a hypothesis test starts out with a hypothesis, a claim, something that you feel in your gut, something that you've seen, something. How many times have we said, oh yeah, I watch people all the time, they make right on red and they don't even stop. I think the majority of people don't stop. That's a hypothesis. To test the hypothesis, you would go out and get a sample. You would sit on the corner and count how many people make right turns, and of those, how many stop or how many don't stop. Then you do your hypothesis test based on that. That's the kind of thing. So hypothesis test takes what your sample is and tests it against your gut feeling, what your hypothesis or your claim is, and sees whether there's statistical significance to it. So for example, if I have 1,090 consumers and I ask them if they would have drones deliver purchases, 545 of them responded no. Well, is that statistically significant? I think that the majority claim that they don't, that the majority say no. And so I make a claim, majority means greater than 50%. So my claim is P is greater than 0.05. Well, the big picture is that claim statistically significant? Is it significantly high enough to prove it? Okay, so my claim is that P is greater than 0.5. Now, if I get a 50.1% in my sample when I run it, that's fine, but is that far enough away from 50% to give you confidence that there's the majority don't want a drone delivery? Probably not. On the other hand, if I got 99%, clearly you would say that's a significantly sample. I would go with that and claim that that's what happened. On the other hand, if I get a 54, which I did, is it significantly high? Well, it's not obvious. And there comes the hypothesis test. And what I've done is I've taken out of a textbook a list of what the procedures are for a regular hypothesis test. And I've lumped them into groups, 5 groups to be specific. So what you start with is you identify the claim. And when you're looking at your problems, you should really try to find the pieces to these 5 pieces of this puzzle, because it will help you to answer the questions much more easily in any kind of problem that you get. So first thing you're going to do is identify the claim. In my example, the claim is that the majority of people don't want drone deliveries. That's in my vernacular language. The second part of that first step is to write it symbolically. And that's when you write the P greater than 0.5. That's what the mathematics is that represents the original claim. The next thing is to write what is called the null and alternative hypothesis. The alternative hypothesis is the key because it tells you what kind of a test it is and gives you a whole bunch of other stuff about it. The alternative hypothesis needs to have either a greater than, a less than, or a not equal sign in it. So in my case, I'm claiming that the proportion is greater than 0.5. So my claim would go into the alternative hypothesis. The null hypothesis is basically status quo, and that's always written as P equals whatever the number was. So in this case, it's P equals 0.5. So we have to learn how to write the hypothesis. Also, the alternative tells me what kind of a tail this is. Now, again, this may not be clear to you at this point, but it will as it moves on. So if it's a greater than symbol in the alternative, it's a right-tailed hypothesis test, less than hypothesis test, and a two-tailed hypothesis test. The next piece of part 2 is to choose the significance level. What is your risk? How adverse to risk are you? Type 1 risk error says that I'm willing to risk that 5% of the time I will reject status quo in favor that something happened when indeed nothing really should have. And so 0.05 or 5% is the standard significance level. Not necessarily, you don't have to use it, but that's what you'll see in most reports. Okay. Step 3 is to identify the test statistic. Now, the test statistic, once you get it, is used in the same manner as it is in all hypothesis tests. But the key here is what is the formula for it. And so I put those formulas into the Excel spreadsheet, but I'll list them here for you. If I'm doing a proportion test, I'm using the normal sampling distribution to compare it to. And as long as the n times the probability of any one event occurring is greater than 5, then I can use this formula. Z is equal to p hat, which is the proportion of the sample, minus what my claim is, over the square root of the claim times its complement divided by n, the size of the sample. If I'm doing a means test, I have to pick between the t sampling distribution or the normal z. The key here is sigma known or not known? If sigma is not known, sigma being the standard deviation of the population, then I use this formula and this distribution. If sigma is known, then I use this formula. Notice that the two formulas are identical except for the denominator where I use the sample standard deviation, or in this case, I use this population standard deviation. We won't be using this, we won't be testing anything else, standard deviation and variance deviation, so we'll skip that particular one. Now going back to once I have my test statistic, then I can use the test statistic to calculate a p-value. The p-value is the value that we use in order to evaluate whether we have statistical significance or not. We won't be using in class the critical value. And the critical value, while it is simplistic in nature, is not what you will find in most research reports. So we will focus in on the p-value. The p-value is the probability of observing a sample statistic is extreme or more extreme than one observed under the assumption that the statement in the null is true. That means, is the theoretical probability that a sample will result in a statistic such as one obtained if I obtained it by random chance? And it's that I compare against my risk in order to draw my conclusions. Okay? Please be careful. There's a lot of p's floating around in this class. P-value, probability of a test statistic at least extreme. The symbol P, population proportion. P-hat, the sample proportion. Make sure you're clear on what those are. Okay? Last step is to restate the decision and now take it back out of mathematics back into layman nomenclature. And to do that, we're going to use something like this. We're going to say, okay, where did I put the claim? Did I put the claim in the alternative hypothesis? In other words, was the claim greater than something, less than something, or not equal to something? Then it would go in the alternative hypothesis. If I rejected HO, my final statement will be written something like this. If I did not or failed to reject the null hypothesis, my statement will be written this way. On the other hand, if the claim were just equal, then did I reject? This is the way I would write my statements. These are something that you would want to take note of. So this is the basic introduction to hypothesis testing. It is by no means totally clear at this point, I am sure, but there'll be two more videos, one on proportions and one on means, to give you examples going through how to actually do these problems. Thank you.